Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where I am trying to help you to achieve the dream of getting 60 marks out of 60 in your upcoming KCET 2025 exam. And as usual, we have already completed the gravitational chapter. So today what we are going to do? Yes, we are going to discuss the previous year questions from this chapter. And if you are following our channel from the beginning, then you should know that you have to join our WhatsApp channel. The link is given in the description. If you have not yet joined our WhatsApp channel, you are missing a big time. So don't forget to join our WhatsApp channel. Every Sunday we are going to publish question paper, physics, chemistry and maths. You can solve that and we will be providing the answer end of the day, right? So that was the general norm. We have already completed 11 KCET Premier League exam, and we for physics at least KCET Premier League 11th match is over, and next week will be 12th match, and soon we will complete the entire syllabus. 4th of December, the date that I promised at the beginning, that I will complete all the videos, all the chapters. So we are very close to that. Once the chapters are done, then we will do the most probable questions for KCET, chapter revision, crash course. Everything will come after we complete the course. First we have to complete the course, right? And if you are following our channel, it will be very helpful for you to achieve that 60 marks in your KCET exam. Now let's start with previous year questions from this chapter, KCET 2024 exam. What is the question? What is the value of acceleration due to gravity at a height equal to half the radius of the earth from its surface? So for this question, what formula you have to use? You have to use simple formula GH. Do not use the shortcut formula that I taught you yesterday. You have to use the complete formula. G equals to G divided by 1 plus H by RE whole square. This is the complete formula for this question, because RE, the shortcut formula is only valid when H is smaller compared to RE. Now half of RE cannot be considered to be a small value, right? So it will be equal to half the radius, means it is not small value. So what is H in this question? H is given as half the radius of earth, right? So let's put that value here and calculate GH. G divided by 1 plus RE by 2 divided by RE whole square. That is G divided by 1 plus, so RE cancels, there is a half here, whole square. So what is 1 plus half? 1 plus half is nothing but 3 by 2, so whole square. So it will be equals to 4G divided by 3 by 2 square is, so okay, let me write the steps. Okay, 3 by 2 square is 9 by 4, right? So it will be 4G divided by 9. Many of you will ask, sir, how you get that 4, how you write that 4G by 9. So let me write this. Now we have to put the value of G and calculate the value. Okay, 9.81 divided by 9. So it will be 4 times 9 ones are 9, 9 ones are 9.099 are 81. Okay, it will be 1.09, or it will be 4.36, 4.36. Okay, so let's check the answer. From the given answer, this is the closest match, so we will write this as our answer, meter per second as usual, second square, right? So from these given answers only, this is the closest match, so we will definitely write this. Okay, so you have to use this formula. Remember that you have to use this formula to solve this question. Now next question. When a planet revolves around the sun, in general for the planet, so this question is based on the simple concept, linear momentum and aerial velocity are constant. Okay, kinetic energy and potential energy of the planet are constant. Angular momentum about the sun and aerial velocity of the planet are constant. Linear momentum and linear velocity are constant. Obviously linear velocity is not constant. Linear momentum is also not constant because it is changing direction every second, but angular momentum is constant in this case, right? Angular momentum about the sun and aerial velocity of the planet are constant. Aerial velocity is constant, that we know from the fact of Kepler's law. We have learned that yesterday, and angular momentum is definitely constant in this case. So angular momentum about the sun and aerial velocity of the planet are constant. Now, two bodies of masses 8 kg are placed at the vertices A and B of an equilateral triangle ABC. A third body of mass 2 kg is placed at the centroid G of the triangle. If AG equals to BG equals to CG equals to 1 meter, where should the fourth body of mass 4 kg be placed so that the resultant force on the 2 kg body is 0? So we solved the problem yesterday. I am solving it quickly so that if you have missed the yesterday's class, you can still cover it up. So what is the problem? There is a equilateral triangle, okay, and equilateral triangle, and the masses 8 kg, 2 8 kgs are placed on the two vertices. One is A, this is B, and this is C. Okay, and there is a centroid G where we placed another mass 2 kg. Okay, now what is the centroid? Centroid is basically, if you draw the bisectors, then you will get this point which is called G. Okay, and if you draw the bisector, all the three bisectors are will pass through this point, right? Now what else? They said that at G you have placed a mass of 2 kg. Okay, and where you should place a third mass 4 kg so that the force acting on this 2 kg mass becomes 0. Okay, now this is little complicated, longer question, and definitely you cannot place the mass at C. Okay, if you are placing at mass C, then it will not be the answer. You have to calculate the steps. So first of all, we know that on this mass, what are all the forces acting? There are few forces acting on this mass. So first force is acting on this is this force. Second force is this force. So we have to place a third mass along this line joining C and G somewhere here, okay, at point P, so that the resultant force is neutralized. Now basically the resultant force in this case will be definitely in this direction, right? So resultant force will be in this direction. So if I place a mass here, now what will happen? The attractive force will cancel this force. So this force will cancel this force, and gravitational force is always attractive. If you missed yesterday's class, I have done a detailed solution for this question. So I can request you can go back to the yesterday's class and check the solution again. And I am doing the mathematics part again in this class. So what is the force? This force, if you see, this is 2, this is 8. This is 8, this is 2. So the pair of the mass are same, 2 and 8. So the magnitude of the forces will be same. What is the magnitude of the force? Let's say F. F equals to F1 equals to F2. What is the value of F? G M1 M2 by R square. Here R is given, both the distances are given 1 meter. If you read AG equals to BG equals to CG equals to 1 meter. So 1 meter square. Okay, so it will be 16 G, right? It will be 16 G. Now what we have to do? We have to calculate the resultant force R in this case. So what is the resultant force R? R is nothing but, from the addition of vector formula, we know that this is F1 square plus F2 square plus 2 F1 F2 cos theta. Oh sir, you are saying F1 F2 but you are writing only F. What is this, sir? Because F is equals to F1 and F is equals to F2 as well, right? So while saying I said F1 F2, but while writing I have only written F. Clear? Now what else? F square plus F square will be 2F square right? 2f square plus f times f is another f square, 2f square cos, what is this theta? Here is the angle between the forces. What is this angle? So if you know, the equilateral triangle consists of 3 equal angles. All the angles are 60 degrees, and this is the bisector, so this will be 30 degrees. This will also be 30 degrees for equilateral triangle, right? So this is now a triangle, so you can find this angle to be 120 degrees, right? 180 minus 30 plus 30, that is 120 degrees, right? Now, so this angle will be cos 120 degree, right? So you can write this as, now f square will be common and it will come out of the square root, so it will become only f. 2 plus cos 120, what is the value of cos 120? I explained, cos 120 is minus 1 by 2. Okay, so f equals to square root of 2 minus 1, so it will be only f. Simple. Okay, so you have to place a mass of 4 kg somewhere here, say at a distance x, so that this attraction force is equals to f or equals to 16g, right? So suppose the distance is x, the mass we know 4 kg, this mass is 2 kg, so what is that force equals to? That force will again be f, that will be equals to g m1 m2 by x square. It is not 1, you are not placing it at c, so it has to be x square. That should be equals to 16 g cancels, so you can find the value here. Let me clear this part up. Okay, so it will be 2 4s are 8, 8 divided by x square equals to 16, or x square equals to 8 by 16, cross multiplication, right? So x equals to, that should be equals to half, so x equals to 1 by root 2. So it will be at a point at PG equals to 1 by root 2 meter. Interesting question, not simple. Okay, many students, I was checking some of the responses. Most common students are responding it's equal to 2 meter, because the mass is now 4 kg, so distance will be 2 meters. It is not so. Okay, mass is reduced, so distance will also reduce, because it is 1 by r square relationship, right? So it will be 1 by 2, 1 by square root 2 meter. Okay. Now, question number 4. The value of acceleration due to gravity at a height 10 km from the surface of the earth is x. At what depth inside the earth is the value of the acceleration due to gravity has the same value x? So if you followed here our studies lecture, I explained that when suppose the height, if it is close to the earth, okay, if the height is h, then the depth will be 2h, right, to have the same acceleration. So if here it is gh, it will also be gh. This is the surface of the earth. Okay, here h equals to 0, so here also will be gh. So here this is given as 10 kilometers. So same value x will be at a distance 2 times 10, that is 20 kilometers. Okay, so it will be 20 kilometer. Very important concept. If you remember this shortcut, it will be very easier for you to answer such questions. Okay, now question number 5. A satellite is orbiting close to the earth and has a kinetic energy k. The minimum extra kinetic energy required by it to just overcome the gravitational pull of the earth is. Very interesting question. So satellite is orbiting, a satellite is orbiting very close to earth, right? So very close to earth, what is its potential energy? The potential energy is given by gm, mass of the satellite is small m, by r, right? This is the potential energy. Now when it reaches the maximum distance, that is when it goes to the maximum distance, then at that point of time, what is the potential energy? At that point of time, potential energy will be 0. right? So at this point the kinetic energy is given by K, right? So now we know that what is the work done in this case? The work done required to take it out from the surface of the earth to infinity. This is at infinity, this is close to the surface of the earth. Okay, so it will be delta V, that is equals to Gm m by r, right? This is the energy that we need to make it free. Now here, what is the relationship between kinetic energy and potential energy? When the satellite is rotating around the earth, okay, its kinetic energy is basically the same as the potential energy, right? So kinetic energy should be same as potential energy, so kinetic energy is also V, right? So that should also be Gm m by r. So the extra energy, that the extra work done that you need to do is again equals to K. So the correct answer is K. So when it is rotating around the earth with the kinetic energy, you need the same amount of energy to make it free. Okay, clear? Let's move on to the next question. A mass m on the surface of the earth is shifted to a target equal to the radius of the earth. Okay, so if r is the radius and m is the mass of the earth, then the work done in this process is. So very interesting question. So mass m on the surface of the earth. Okay, then you have taken it to again the height equal to the radius of the earth. Okay, and they asked you to do what is the work done. So work done, you are trying to calculate work done. Initially, when the mass is on the surface of the earth, then what is the potential energy of the system? So the potential energy of the system was Gm, mass of earth, Gm by r. This is the initial potential energy. Now when it reaches here, what is the potential energy? In this case, the distance increased to 2r. I solved this question yesterday. So V2 will be equals to Gm m by 2r, right? So what is the work done? Work done is V1 minus V2, that is Gm m by r minus Gm m by 2r, or again it will be Gm m by 2r. Okay, you can consider this to be 1, this is half, so 1 minus half is half, right? But in the option, if you see, nothing is given about either G or M. Okay, so what we have to do, we need to replace this value with G. What is G? G is nothing but Gm by r square. So what we will do, we will replace Gm by r equals to Gr. We have multiplied r on the both sides, right? So we can replace this term Gm by r times m by 2. So we can replace this using Gr. So Gr times m by 2 or mgr by 2. So mgr by 2. So correct answer is option A. Now next question. Which of the following graphs correctly represents the variation of G on the earth? So how? I have already explained which of the graphs during our lecture. The correct answer is this. It initially increases linearly and then slightly exponentially decreases. So correct answer is option B. It is not like this. It's like this. Okay. Now, okay. A space station is at a height equal to the radius of the earth. If v is the escape velocity on the surface of the earth, the same on the space station is dash time v. So there is a printing mistake here. I apologize for that. Okay, it will be dash times v. Okay, so what is the escape velocity on a space station which is located at a distance equal to the radius of the earth. So basically this is the escape velocity when on the surface of the earth, the escape velocity is v. Okay, on distance, say at a distance r, what will be the escape speed when it is at a distance r from the surface of the earth. So what is the formula for escape velocity? The formula for escape velocity, we know that it is equals to square root of 2gr when on the surface of the earth. Okay, now what will be the escape velocity when it is at some distance at height h? So for that we have to use the concept of escape velocity and understand it in depth. Okay, so concept of escape velocity states that the work done, or basically the difference in potential energy, should be equals to the kinetic energy required by it. Okay, so what is the difference in potential energy? The difference in potential energy on the surface of the earth, we can say from there we have calculated this value. So here what is the potential energy? The potential energy at this point, okay, the potential energy, say P, at point P is given by gm m by this distance r plus r. We have already done it in our previous problem, so it will be gmm by 2r, right? Or we can write this as gm by r times m by 2. What is gm by r? We already know that gm by r is nothing but gr, so we can write this gr m by 2. Right, so this is the potential energy at this point. Now if we give it a escape velocity v, okay, then what will be the kinetic energy? The kinetic energy will be half mv square, right? The kinetic energy will be half mv square, and that should be equals to the kinetic energy. The potential energy has to be equals to the kinetic energy so that it can evade Earth's total attraction and can reach to the infinity. So they has to be equal. So now we can cancel mm, this half will also cancel. So v at this point, suppose it is ve, okay, so ve square equals to gr, or ve equals to square root of gr, or it is equals to square root of 2gr divided by root 2. So we have multiplied root 2 in the top and bottom, so it will be 1 by root 2 times v. So it will be 1 by root 2 times v. So correct answer is 1 by root 2. Right, so this is the correct answer. Slightly tricky question. You need to know the concept of escape velocity to solve this question. I skipped this concept during a class, thinking that maybe it is not important, but yes, it is important. One question came in 2018, so not so far away either. Now question number 8 from 2017. The value of acceleration due to gravity at a depth of 1600 km is equal to, what is the value of acceleration? Direct question. It's a very direct question. So g at a depth d is given by g on the surface, okay, times 1 minus d by r. If you remember, this is the formula. Directly we have calculated that. So g is they have not mentioned the value of g, but I am assuming in 9.8 because in the option they have given 9.8, so I am writing 9.8. and what is the value? Here d is given 1600 kilometers. Now note that in this case we don't need to convert it into meters. Why? Because it's a ratio of 1600 kilometers and 6400 kilometers. Right, so both are kilometers, so we don't need to convert it into meters. So as long as both are in meters, I don't need to convert it. 1 by 4. Okay, so 9.8 times 1 minus 1 by 4. Okay, so it will be 9.8 times 4, it will be 4 minus 1 by 4, so it will be 3 4 by 4. Okay, so it will be 3 by 4. So let cancel. 2 4s are 8, then it will be okay, let's take this as 10 only. We will approximate, don't worry. So 4 times 10, it will be 2.5. So what we have done, we have taken the value of g as 10, okay, because it will be difficult for me to calculate, little difficult, not so difficult, but I don't want to go into that mathematical calculations. So it will be 2.5 times 3, that is 7.5. Now let's see which one is the closer answer. So closer answer is obviously, the obvious candidate is 7.35, right? So I can easily say this is the correct answer, because we have assumed 10 and our answer is 7.5, so actual answer should be slightly lower than 7.5, so it will be 7.35, right? If you remember the one formula, one question, right? Next. Variation of acceleration due to gravity with the distance x from the center of the earth is best represented, r is equal to radius of the earth. Again same question. So two questions came in previous years, only they have changed the graphs, right? So this is also very important. How the gravitational acceleration changing? It is changing like this, right? This graph is more accurate. Now next question. If the mass of a body is m on the surface of the earth, the mass of the same body on the surface of the moon is m by 6. Raise your hand if you are saying m by 6 before I reveal the answer. So obviously if I say raise your hand, that means it is definitely not the correct answer. The correct answer is m. Okay, correct answer is m, because mass does not change wherever you are. That is the fundamental property. Mass of an object is fundamental property and it does not change no matter where you are in this universe. Okay, in a different universe with different laws of physics, maybe it will change, but in this universe where we live, we see, we breathe, in this universe, every planet, every star system, solar system, mass does not change. Okay, the force of gravity will change, the acceleration of gravity will change, the weight will change, but mass will remain constant, so it will remain m. Okay, if you just reading the question mark it m by 6, stop this habit, try to understand. Okay, so this is a very very old question, and I don't think this question will come in your KCET exam, but this is a very trick question, trust me. Okay, in 2015 I know many of the students who appeared for this paper, they answered it m by 6. So don't do that. Okay, think twice before answering a question. Next, period of geostationary satellite. So geostationary satellite means which moves along with the earth. Okay, so it is there is a satellite, there is a orbital distance from the earth that can be measured. Okay, at this distance this satellite appears to be stationary at the same position when we look from the earth, and it is actually on the along the equator only. Okay, the geostationary satellites can be parked in the along the equator only. Even our India has a specific spot, okay, so specific area where India can launch geostationary satellite. Okay, because equator is not passing through all the countries in the world, so each of the countries, they have divided certain areas where each country can park their geostationary satellite, and from there it can locate, it can look towards earth, towards that country, particular country, any point of time, and it will stay there throughout. Okay, as we are moving, it is also moving. So what is the time period of Earth's one single rotation? Earth's single rotation around its axis is 24 hours. So geostationary satellite will also rotate once about 24 hours. So it rotating around with 24 hours, so that it is rotating with a speed such that whenever we are looking in the sky, they are appearing to be static because they are rotating along with us. So its time period is 24 hours. Now next question, the last question. What is the period of revolution of Earth satellite? Ignore the height of the satellite above the surface of the Earth. We solved this question yesterday, and that is 85 minutes. We know that any Earth satellite around the Earth, rotating around close to the Earth, has a time period of 85 minutes. So it is 85 minutes, not 83.73 minutes. It is 85 minutes. The problem is solved in your NCERT book as well. If you want, you can check the calculations there. The formula for that is given by T equals to 2 pi square root of G by R, right? So this is the formula. You can use this formula to calculate the time period. Put the values given in the question, but the answer will be, you will get the answer in minutes. You have to convert it into seconds before answering. It is not G by R by G. Yes, it is R by G, right? So you can put the values of say 6400 kilometer, but here you have to remember that you have to convert it into meters first. Okay, calculation is very simple. You can do the calculation and you can calculate. Okay, it will come out to be 85 minutes. Now, if you are watching this video for the first time, if you are new to our channel, don't forget to subscribe to our channel, and to all other members, those who are watching our videos for the long time, don't forget to share with your friends so that they can also score well in KCET 2025 exam. I will be back with a new chapter tomorrow. Till then, bye.